Hey, welcome back to the 10th episode of the Decomposition Pattern podcast, where we break down the hardest stakes in tech and programming into their fundamental components. We separate signal from noise, tackle complex topics with clarity, and rebuild our understanding from the ground up. This is Jose, and today I think we need to talk a little bit about the balance between quality and deliverability of software. This topic was requested by a listener of our podcast, Danielle. This is not the first time that he makes a request. This is also a signal for you all can request topics for us to discuss here. So his request was very simple. How can we balance delivering the best software in the least amount of time or in the quickest time to market, right? And there are a few things that we first need to align in our expectations, like what's our own definition of a quality software, right? I have one. That's the one I'm gonna share with you, but you might have a different one. So first, we need to align in what is quality software. For me, quality software answers three major topics in software. First of all, the software does its job. It handles the known knowns and the known unknowns. What does this mean specifically? The known knowns is the happy path. So you receive valid input, you do your job, you return successful responses and everything, and the output is achieved. The known unknowns is how the software responds to known invalid things. Like I send you invalid payload. Should we add validation on the inputs and ensuring that they are valid and they are of expected types, and then eventually validating that everything goes according to plan, and if not, returning a very human readable result, right? So it's either achieved its goal or it failed because of this, so people know how to handle and doing or resending the data in a valid state. That's the first thing. The second thing is a mix of two. Is the software deterministic and is resilient? What does this mean? This means that the software responds the same for duplicate inputs, right? So if I request twice the payment of a service, right, through like a request, I send a payment for one of those payment systems, right? You for some reason you send twice the same request, like same card, same value to the same people. The software should not attempt to charge that operation twice, but should return the same response twice. Right, saying, hey, this has been charged, even if it only went charged once. Obviously, there are contexts where software determinism is not required. If you're doing a to-do app, it's just not valid, a valid investment of your time, right? But if you're doing a payment system, damn sure it should be. So that's the second thing. And the third thing is, does the software or the product has documentation? And I'm not talking about technical documentation. I'm talking about like customer-facing documentation, something that you can point customers to for them to self-serve and self-resolve their own problems. That can lower the need for customer support, and that can allow you to invest time in things instead of answering over and over again to the same questions, right? So those are like 3-4 things that I look into when checking if a software has quality or even developing my own software. Does the software, repeating again, does the software does its thing, is resilient at least, and deterministic at best, and has the documentation to support and explain how things work. So how then to answer the bigger question, how to balance this in the least amount of time? There's also another thing that we need to agree on, that at least in my experience I've seen it happen all the time. No matter how long or how much time you can or you decide to invest into something, that work, that something, that project will expand itself to use the entirety of that available time. So if you say I have 2 months to develop this software, you can be damn sure that the software will take 2 months to develop, because, and that's the kicker, right? That's the biggest point I want to share with you. That's this balance, because we are going to develop the software in iterations that will allow us to develop the best software in that available amount. And this is my approach into doing this. I make sure that the software does its job first. I take whatever time required to make the software handle well to the known knowns and the known unknowns, right? So the software does its job. It has some safety for reacting to invalid input, to problems, to third party. If I'm interacting with third parties, to react to their failures, right? And I have the required architecture to handle that. And if I have time after doing that, and I put developing tests in this same box, right? So having the tests, I don't need 100% code coverage, but I need to have tests for at least the most critical parts of my system, and that will be the happy path and the known unhappy path that my software can be. So that's the first thing. And if I have time, then I go into the second iteration, which is how can I add resilience to my system. And this, to be more concrete, is where I look into ways of adding observability to the system, right? So that's where I want to add all of those logs and traces and metrics, so when I have some problem, I can check and debug by making my software redo those steps that it took to answer that request, to do that job, so I can see what went wrong. And if possible, that's the resilience part, or the most important part of resilience, I can repeat those operations, so I can, if not yet, I can make the software fulfill its objectives, right? So these would cover the cases where I get a very valid input, but then for some reason the software has a bug and can't fulfill and fails miserably. Now there are two things that happen here. I either have thought out about resilience and add those logs and traces and whatever that can lead my system to recover itself, either by manual intervention from my side or of my team, or automatically, because it will try again. It failed with connecting with a third party. Maybe it was unavailable at this time, and then 1 minute or a few seconds later it's already available and I can retry. So that's the resilience part. But the goal being, how can I recover from this without my consumer, right? Without my customer to resend the entirety of the payloads to make the job work again, or make the software work properly, right? So that's the part where I'll add resilience. Another example of resiliency is like I have a new deploy and it had my errors rate went through the roof. My system can automatically detect that and revert to a previously known stable state. All of these seem simple, but they are very complex in terms of architecture and require a lot of time. That's why we are going into iterations, right? Depending on how much time I have left, we are going to add these more things to our solution in order to achieve the bigger goal, which is I develop or I deploy the best quality software in the amount of time that I have available. And third, how can I I'll add the documentation. So if I have any more time, I'll add the documentation. This is a very sensible topic because deep down, and I'll honestly try to have the time to do the documentation. And there are some development patterns that we can add to ensure that no matter how much time we have documentation. But in the end, it will always, if I have to sacrifice things, the first thing that I would sacrifice is the documentation in favor of having my software doing its job, and if possible, being resilient in a way that maybe I don't need my customers to freak out about resending data or worrying about where is my data, things were registered, or the software did its job or not, right? But there are patterns where we can include this third thing, this documentation, into the development itself, so that I always have some kind of documentation, right? But if needed, that's the first thing. That's the thing that I would sacrifice the most, at least in the first iteration, or meaning in the time that I need to go to market with this idea, then I would probably go, if I didn't have the time, then I would probably go and have a project of update the documentation after developing and being delivered the software. Now then it comes if we go through with that or not, that depends on you and on each of you. If you go really being that dedicated, sacrificing the documentation, then adding right after the development. So all of this brings trade-offs, as you might have guessed. But if we go into this and follow this general plan in having 3 iterations during development, I think we will always reach the best quality software that we can in a given time. Okay, so example, given 3 months or 2 months, I will make the software do its job, then I will make the software be resilient, and then I will focus on documentation. But I will try to do these 3 iterations during the software development in that time given. And that's it. Basically, there's not much more to it. So Danielle, I hope that you were answered and this answered your question, but do feel free to come back with follow-up questions if you have it. I'm very happy to share more and go into more detail if needed. And that's also a call out for the rest of you that are listening. If you come interact with us, join our Discord server. You just access discord.thedecompositionpattern.com. You'll be invited to our Discord and come and interact with us. Share how have you thought about this? How do you balance quality and delivery of software? Come exchange ideas. We'll all learn and grow with each other, right? Until then, I have a very nice day, and until the next episode.